Well, welcome back. Goal today is to introduce you to, some concepts you're already familiar with. We're just going to refine your familiarity a bit. So a lot of today we're just going to be talking about the notion of consistency and inconsistency. But I'm going to introduce you to a few other things along the way, the analytic-synthetic distinction, and if we have time, the a priori, a posteriori distinction, which will also be relevant for thinking about theory of knowledge later on in the semester. All right, so statements. This is where we begin. In talking about logic, and talking about consistency and inconsistency, and talking about contradiction, we're talking about relationships that obtain among statements. Statements are things that you're quite well aware of, you're very familiar with. Statements, claims, philosophers often prefer the term proposition. And there are things like these. The cheese is old and moldy. Cheese is fresh. Chocolate tastes delicious. Chocolate tastes exactly like soap. You can tell this is just stream of thought, right? These are just things I thought of as I was constructing this slide. Paul is viewing an image of the Mona Lisa. Paul is in France. All right. These are just sample statements. We could have picked anything. We could have started describing this room. You're sitting in a bluish chair. You're sitting in a room. There's a ceiling over your head. Right? All sample statements. Not every sentence is a statement. This is something you should know from your elementary education. Right? We have questions. Right? We can ask, is the cheese fresh? This is distinct from a statement, in part because statements are capable of being true or false. Questions aren't. To ask a question isn't to say anything that's true. It's not to say anything that's false. Are you here now? There's an answer to the question, and the answer is going to be true. At least the correct answer is going to be true. But the question itself is not true. Questions and statements don't exhaust sentences, right? We have commands. Throw out the cheese. Sit down silently. Clean your room. These are instructions. But again, these aren't sentences that are either true or false. To issue a command, commands can be good or bad. Commands can be rightly or wrongly given, maybe, surely. But they're not true, they're not false. Right? Exclamations are another kind of sentence, or speech acts. If you're at a game and you're cheering for a team, right, you go, hooray, yeah, go Bulldogs, or something. We can make good sentences out of these sorts of things, but again, these aren't true, they're not false. All right, so what's distinctive about statements is, first off, they purport to describe the world. Right? They, if true, correctly describe how things are. And along with that, they're capable of being true if they do, in fact, correctly describe how things are. All right, so when is a statement true? You know, it's funny, in both classrooms I teach in, I'm having this problem where the projector flips on and off. It seems improbable. Okay, so here's the standard answer. A statement is true. And remember, statements are linguistic utterance. We have the statement, the grass is green, the cheese is moldy, you're in a room. And we want to know, when is a statement true? Well, here's the answer. The statement, the grass is green, is true just in case the grass is green. All right, now this should sound, in one sense, utterly trivial, but perhaps in another sense be just a little bit perplexing. Where do our slides go? All right. Okay. Let me back up just a second. So you're in a room. All right, so I just made a statement. What is it for that statement to be true? For it to be true is for the world to be a certain way. It's for reality to be a certain way. It's for things to be a certain way. What way? Such that you're in a room. So the idea behind truth is a very straightforward idea. It's a familiar idea. And it's just the idea of the world being a certain way. And when a statement is true, when a statement has the property being true, it's just that the world is as the statement says it is. So you might think of statements as pictures or possible pictures of the world. And when the picture correctly represents how things are, the statement gets the value true. And when the statement incorrectly represents how things are, it gets the statement, it has the value false. Okay? So in some sense, there shouldn't be anything mysterious when you think about truth. Sometimes people ask the question, what is truth? Pilate's question. What is truth? And there is probably something deep being asked there. But it's not, it shouldn't be taken as mysterious, or at least the question, when is a statement true, shouldn't be taken as a deep, very difficult question. A statement's true just in case it accurately reflects how things are. Okay. All right. Any questions about truth? Any questions about statements being true? Great. Often you'll see in philosophy, or at least if you keep studying philosophy, this, what you might take to be a misspelled if. The if with an extra F is not a misspelling. It's philosopher's shorthand, and it's an abbreviation for if and only if. Okay. A, if and only if B. There's a less formal way of expressing this idea. We can say A just in case B. And it's just a way of expressing two different conditional statements. If you say something if and only if another thing, you're saying if the first thing, then the second thing, and also if the second thing, then the first thing. All right, so it's just a compact way of referring to a pair of conditional statements, a pair of if-then statements. Okay. All right, so again, simple stuff. Oftentimes, truth is confused with belief, and you hear people saying things like, well, that's not my truth, or, I don't know, funny things like that. True for you, not for me. The way to make sense of this talk, if it is indeed sensible, is just to acknowledge that, well, when you have a belief, to believe you're in a room is to take it as true that you're in a room, right? When you have a belief, you're representing the world in a certain way. And the belief is true just in case the statement believed is true, and the statement believed is true just in case the world is as the statement represents. For you to have beliefs is for you just to take a certain set of things to be true. And so if you say it's true for you, not for me, that means, well, you represent the world one way, I represent the world a different way. But it doesn't follow from that both are true, or that one's true for you and the other's true for me. It's just that we take different things to be true. So we talk about statements because they're elements of contradictions. Contradictions are a particular kind of pairing of statements. You've got a contradiction whenever you have a statement of the form P and not P, where P is just a variable for a statement. All right? And we say that P is the contradictory of not P, and vice versa. Not P is the contradictory of P. All right, so I'm hungry. That's a statement. It's either true or false. It's true if the world is such that I'm hungry. Right? I'm not. I ate before I came. Now, the contradictory of I'm hungry, well, here's one way to put it. I'm not hungry. So I'm hungry and I'm not hungry are contradictories. It's not the only way to put it, right? You can say it's false that I'm hungry. You can say it's not the case that I'm hungry. You might simply say, I'm full. Right? These are all different ways of saying the same thing. So there's a lot of different ways of expressing contradictories. Somewhat more convolutedly, you can say, I'm not full, and that's the contradictory of I'm hungry. People who talk this way are frustrating because you've got to process things a bit more, but all right, there are all different ways of issuing the contradictory of I'm hungry. Any questions about this? Pretty straightforward stuff. Baby distinctions, great. All right. Something more interesting. Something we've talked about before, law of non-contradiction. Its statement is simple. It says there are no true contradictions. That is, there's no pair of statements that are contradictories that are such that both are true. All right? There's no statement such that P is true and also not P is true simultaneously. Okay? So let your imagination rip for a second. Think of any statement whatsoever. The principle says whatever comes to mind and whatever possibly could come to mind, it's not going to be the case that it is true and its contradictory is true. Okay? So Australia's in China. The law of non-contradiction says it can't be the case that that's true and also the case that that is false. Which is another way of saying it's contradictory. It's not the case that Australia is in China is true. Now, you gotta, so sort of neat things about formulations of laws is that they're perfectly general, right? They say something about a wide range of cases, right? And here the wide range of cases are all possible propositions, right? So again, just let the imagination rip. Any proposition that comes to mind, the law says it's got to conform to this rule. If it's true, its contradictory is false. Okay. Why think this principle is correct? Like, what's the motivation? I mean, why this? Right? Why this law? Well, here are some things people have drawn attention to in favor of the law. So first of all, its denial is seemingly unintelligible, right? What's its denial? Its denial is to say that there are some propositions that are true and their contradictory is true. All right, so what's that like? Well, that's like this. You're in a room now and you're not in a room now. Both are true. Right, that's what it would be for that kind of contradiction to be true. Now, the statements are good English statements, right? We haven't said anything ungrammatical. So in a sense, each part of the entire contradiction is intelligible, right? You know what it means to say you're in a room now. You know what it means to say you're not in a room now. But the unintelligibility argument says you can't understand both being true simultaneously. Right? This is nonsense. Right? Not in a pejorative sense, in a sense like you can't understand what you're saying. It's like making a claim like this. Green ideas sleep furiously in spring. What in the world could that mean? Right? It's a good English statement. Right? It's not ungrammatical. It's just right, unintelligible. Right. Any pushback? Do you feel like you could give an instance of a contradiction that you think is intelligible? Right? Can you picture the world in your mind's eye in such a way that it could be one way and simultaneously not be that way? Right? That's what you have to do to undermine this argument. You have to say, no, there's a range of cases, or at least one case. Right? That's all you need to refute a general claim. Right? You just need one counterexample, because this is a principle about all possible cases. So you just got to give one case. So in the sense, the task is easy. In another sense, it's kind of hard. But to refute the intelligibility argument, you need to provide an instance of a fully intelligible case where it's true that some proposition obtains, but also false that it obtains, and both are true. I think I said that confusingly. Right, just you're in a room here now, you're not in a room here now, both are true. Right, you got to make sense of that. Or some other proposition. Just pick the one you like. Any thoughts? Any attempts?
Quantum physics, if you could necessarily say that they actually understand that, or if that's just kind of a cop-out?
So you've gestured in the direction of something, but you haven't yet given the example. Yeah. All right.
Two things at once.
Okay.
Perhaps that's just a way of saying something that can't quite be expressed yet, but that seems to be the way that one would explain it.
Yeah. So there are these. I just know the echoes of what goes on in the halls of science, and I've heard these echoes of talk of superpositions, and the idea being there's an interpretation of quantum mechanics that would entail that something is both the case and not the case simultaneously until some observation takes place. It's an interpretation, right? So it's not taken to be like wildly confirmed science. It's just a possible way of interpreting things. Now, if that interpretation turns out to be correct, then we've got a counterexample of the principle, and then we have to refine the principle. I'll come back to that in just a second, the refinement bit. All right. But if it's true, if this is indeed a counterexample, it would be an intelligible, arguably an intelligible case where you have a true contradiction. Here's another thing to say in favor of the law, right? Our experience of the world confirms this. We don't experience contradictions, right? We don't walk out the door on any given day and witness the world being one way and simultaneously witness it not being that way. Right? We don't experience contradictions. And the fact that we don't experience contradictions and people throughout history haven't experienced contradictions provides an inductive argument for thinking that there are no contradictions. Right? It's not a knockdown argument. It could still be the case that everybody's had a certain range of experiences, and yet the world is such that one could have an experience that's not in that range. But the fact that our experiences provide so much confirmation of the principle provide, some non-trivial reason to think the principle is true. Right? The fact that you never open up your cupboard and see sugar and simultaneously see that there is no sugar. You don't discover one day that someone likes you and that they simultaneously don't like you. Right? When you're using the term like in the same sense. Right? Someone might like you in one respect and not like you in another respect. But that's not a contradiction. Right? That's just using the term like in two different ways. And lastly, logic is part of mathematics, right? This principle is a part of mathematical reasoning. And mathematical reasoning is a part of science, and science is quite good at predicting how the world is and helping us discover how the world is. It would be really strange if this way of investigating the world that's so successful turned out to employ a principle that's not true. Right? So it gives us some reason to think the principle's true. And also in probability. If you study probability, you're given 3 axioms, and from those axioms and logic, right, the law of non-contradiction and some other principles of reasoning, you derive a lot of theorems, and you get these conclusions about the relationship, about probability relations. And probability is a really useful way of predicting how things are likely to occur in the world. And again, it'd be really odd if we're using a principle to derive theorems that so well depict how things are, or at least are likely to be, rather. If we're using principles to derive things about probabilities that were false, the general principle being false. Right? So again, there's... Right, this isn't... well, let me give you a counterexample, right? So I've just said a lot of stuff in favor of the principle. Let me give you a reason to think maybe the principle is false. Okay. If you take philosophy long enough, you'll encounter this. It's called the liar paradox. It goes like this. I take the statement L. Now, L is a self-referential statement, right? It refers to itself. L says L is not true. All right. So it's just a statement. This statement is false, where this refers to the statement itself. Okay? So L says that L is false. Now, take the law of excluded middle. This says that every statement is either true or false. We encounter this in the argument for fatalism. This, too, is a principle of logic. And the same things can be said in favor of it that can be said in favor of non-contradiction. Not the very same things, but a lot of them. Now, what happens if L is true? Well, L says L is false. So if it's true, then it's false. Law of excluded middle says every statement is either true or false. So what if L is false? Well, then L is true, because L says L is false. So if it's false, then it's true. If it's true, then it's false. So what should we conclude from this? Right. Well, there have been a variety of reactions. Some have said self-referential statements are meaningless. Right? They actually don't have a meaning. This is kind of a difficult position to take because it seems like we understand it. Right? In what sense, then, is it meaningless? Some have taken it to be a decisive reason to reject the law of excluded middle. It's false, in other words, that every statement is either true or false. There are some statements that are neither true nor false. Philosophers will sometimes say that there are truth-value gaps. Okay? And L is just one such gap. Others have said, no, there are some true contradictions, and L is among them. That is, L is both true and false. And if L is both true and false, then the law of non-contradiction can't be right, because the law of non-contradiction says, for any statement you can think of, it's either it can't both be the case that it's true and it's not true. Now here's the thing. There's a really interesting sort of lively conversation going on in philosophy about the status of sentences like this. This isn't the only kind of problem for principles of classical logic. But even the logicians who think that the law of excluded middle or the law of non-contradiction are false, they'll still say that there's a restricted set of sentences or propositions for which these principles do hold. And you only get these weird kind of cases when self-reference gets in the mix, when you get sentences that refer to themselves. Right? It's this self-referential feature of language that generates problems. But when it comes to scientific reasoning, when it comes to reasoning about the world, when it comes to reasoning about your everyday life, the law of non-contradiction is good. It holds. It's just there's a funny portion of language for which these principles fail. And so there's restricted versions, qualified versions of these principles that are just fine. They're great. So here's a challenge to the principle. Still, we shouldn't go around thinking, even by the lights of logicians who take this kind of objection seriously. They don't think that you should begin thinking that one day you might open your cupboard and discover there's salt and there's no salt. They don't think the world's like that. They don't think that you can solve hard problems of time travel, for instance, by rejecting this principle. Right? They're not going to solve problems of time travel that way. They're just going to say that where there are true contradictions, it's limited to a certain aspect of sentences, a subset of sentences of the English language. Any questions about this stuff? All right. So let's talk a little bit more about contradictions, inconsistencies. All right. Contradictions, right? A contradiction is any pair of statements like this, P and not P. Right? That's a contradiction. An inconsistent set of statements is any set of statements that would generate a contradiction if true. Right? An inconsistent set of statements is any set of statements that would generate a contradiction if true. All right. So take this example. Everybody left my home. I'm still at home. This is not a contradiction. 1A is not the contradictory of 1B, right? Because what don't we have? We don't have a pair of statements of the form P and not P. But from this pair of statements, we would get a contradiction, right? If both were true, we could infer a pair of contradictory statements. For instance, if I'm still at home, then it's false that everybody left my home. See that? If I'm still at home, it's false that everybody left my home. And everybody left my home, and it's false that everybody left my home, are contradictories. So these are not contradictories themselves, 1A and 1B, but if true, they would imply a contradiction. All right, here's another example. Charles is presently unhappy. Charles doesn't now exist. These aren't contradictories because they're not of the form P and not P, but they imply a contradiction. Because in order for Charles to presently be unhappy, Charles has to presently be. He has to exist. And it can't both be the case that Charles exists and it's false that he now exists. That's a contradiction. All right. We could give more examples. All right. So here's a quiz for you guys. Here are some pairs of statements. Why don't you turn to the person nearest to you and determine whether or not they're inconsistent or contradictories or neither. All right? So take a few minutes. All right, let's see where you guys are at. Number one, Jack knows that Jim is in the room. Jim is not in the room. Who thinks that this is a contradiction? Nobody? Good. Who thinks that these are inconsistent? All right, some of you. Somebody care to say why?
Because if he knows something, it must be true.
All right, good. We've talked about this assumption prior in previous lectures. To have knowledge is to know something that is true. So if Jack knows Jim is in the room, then Jim's in the room. And that's the contradictory of 1B. So what we have here is not a contradiction, but a pair of inconsistent statements. All right, what about 2A and B? Contradictory, inconsistent, or neither? Yeah, neither, right? Something can be vastly improbable and still happen, right? Planes crash, yet we still fly. Right? It's very unlikely, but it can happen. There's no contradiction there. Tim is happy. Tim is faking a smile. I hope you all see that that's obviously neither. What about 4A and B? It's rational to believe Jim is in the room. Jim is not in the room. So who says inconsistent? Who says neither? All right, most of you. Good. What does that tell us about rationality? How does rationality differ from knowledge? It's not fixed on truth. All right, that's one way of putting it. You can have rational false beliefs. Yeah, you can have rational false beliefs. What about the last one? Are these inconsistent? Or are they neither? All right, so think about what 5A says. All swans are either black or white. Now it's a claim about all swans, all actual swans. Now, can it be true that all actual swans are either black or white, and yet there's a possibly pink swan? Genetically modified pink swan?
Currently, all swans are either black, but it's possible for them to like.
I don't know, what if you spray it down with like pink paint?
Yeah.
So I feel like you want to say these are inconsistent. Actually, here's a way of making them inconsistent. Maybe facts about, so maybe the thought is all swans are genetically either white or black. And maybe the thought is if something's genetically either one way or another, then there's no possible way to have that kind of thing and have it be some third way. And that would be an inconsistency. But this is just a claim about the superficial color of these things. All right? And we could paint down a swan any color we like. So it could be true that all swans are one or the other color, and yet also possible that they be some third color. So these are consistent.
Might it be quite conceivable that if a white swan was to eat the same algae that pink flamingos eat, then it might likely go extinct?
All right. And then it would be false that all swans are either white or black. Yeah. So remember that the claim of inconsistency is this. It's any pair of claims which, if true, would yield a contradiction. You can have inconsistent statements where neither are true. Right? So in asking whether or not 5A or 5B are inconsistent, we're asking if they're true, is there a contradiction that follows? If they were true. And if the answer is yes, then, well, they're inconsistent just by definition of inconsistency. Which is why I say the consideration of the falsity of 5A isn't relevant. Right? We want to know if both are true, does a contradiction follow? Which means we don't want to consider possible scenarios in which 5A is, in fact, false.
But could you say that it's possible for that to happen? It hasn't happened, but it's possible. So
Yeah, okay, good.
there are now, at this time, no pink swans, but it's possible that in the future, were certain things to happen, there would be a pink swan.
Good, good.
Or in the past, there was a pink swan and they're now extinct.
Yeah, so you're drawing attention to an ambiguity in 5A. So 5A doesn't sort of specify a temporal parameter. When I used it, I meant to express the thought that all swans presently are one or the other color. You're asking a question about the history of swans in the world, which is, well, you could have just considered a different claim. And if the suggestions you're making are right, then 5A would be false, understood in that historically more expansive way. Yeah, no big deal. We can just draw our attention to any proposition we want, and we can ask whether it and some other one are consistent or not consistent. Consistent, contradictory, or neither? All right, so we're back. Good. I'm going to have to call tech support about this. So who says contradictory? A lot of you. Who says inconsistent? All right, one. Now notice, you can't say a pair of statements is contradictory and not inconsistent. Why is that?
Because inconsistent statements tend to generate contradiction.
Well, by definition, a set of statements is inconsistent if they yield a contradiction. Is every contradiction a contradiction? Yes, every contradiction is a contradiction. So every contradictory pair of statements is an inconsistent pair of statements. All right, does anybody say neither here? Yeah. Do you care to say why?
Yeah, because maybe, in my opinion, you are told something.
Uh-huh.
In his opinion, you are...
All right, good. Some terms of language. All right, so there are two answers to this question. Well, maybe three. So contradictory, inconsistent, and neither. Just depends on how you're reading the statements. Some terms of language are context sensitive. When one person uses the term, it means one thing. When another person, it can mean another. Right? Judgments of tallness or shortness are always relative to, and you'll remember this maybe from the discussion of relativism in the introductory ethics course. Judgments about tallness and shortness are always relative to a reference class. When midgets say someone is tall, they might well be referring to you. But no NBA basketball player is going to consider you tall. Both individuals are thinking about tallness with regard to a different reference class. Right? And there's no contradiction there. You do get a contradiction when you hold the reference class set. Right? When you make the judgment relative to the same thing. Table's flat, table's not flat, right? Ordinarily, you'd consider something like this flat, right? This is flat. But if you're interested in how things appear or behave or look or are at the level of the really small stuff that makes up the world, particles, this is not going to be flat. Right? And it just has to do with the notion of flat you have in mind when you're expressing the statement. All right, so long as you have the same notion in mind with both pair of statements, you've got contradictions. If you don't, then you don't. Okay. You can have a look at those. All right. Now I want to turn your attention to something else. What's called the analytic-synthetic distinction. All right. Some doctors that specialize on eyes are rich. That's true. Some ophthalmologists are rich. Many bachelors are ophthalmologists. People who run damage their bodies. I don't think that's true. I don't know why it's on there. It doesn't matter. Just take the statement. If Holmes killed Smith, then Watson must be dead. All right. All doctors that specialize on eyes are doctors. All ophthalmologists are doctors. All bachelors are unmarried. People who run move their bodies. If Holmes killed Smith, then someone died. There's an important difference between these two sets of statements. Any speculation as to what the salient difference is? All right, yeah. So there's a lot of generalizations here. Not the ones on the left-hand side aren't always generalizations. All right, so there's that difference. There's another difference I want you to draw your attention to. Tell me, with regard to one, some doctors that specialize on eyes are rich. What would you have to do to figure out whether or not that's true? What would you have to do?
Observe one rich doctor that specialises on eyes.
Yeah, Google eye doctors, find one, ask them if they're rich, and then you can know that some doctors that specialize on eyes are rich. Maybe there's other ways to figure it out, right? Maybe your parent is an eye doctor and they're rich, which is good for you, I assume. There's different ways of figuring this out. But what about 6? What do you have to do to figure that out? All doctors that specialize on eyes are doctors. All right, good. 6 is true. Do you have to Google anything to figure out whether or not 6 is true? Do you have to find an eye doctor somewhere? No, you just have to understand the statement. If you understand the statement, you're in a position to see that it is true. That's kind of cool, right? There's some things that you can know are true just by relaxing, sitting in your chair and having a think. Same thing with the rest of these in that second category, second box. All ophthalmologists are doctors. Part of the meaning of the term ophthalmologist is doctor. Right? To be an ophthalmologist, you have to be a doctor. All bachelors are unmarried. Again, you don't have to Google anything. You don't have to go track down a bachelor and ask them, have you married anybody? Right? If you know what the term bachelor means, you know that someone's a bachelor only if they're unmarried. Similarly with running and moving one's body, if you know what running is, you know that there's no way to do that without moving your body.
Sometimes the bachelors could be secretly married and don't disclose that marriage. So there's thus the heritage loss, even though the truth is convenient to not take bachelors.
If someone's married, they're not a bachelor. You can parade as a bachelor, right? You can say you're a bachelor. You can be on the show The Bachelor. Perhaps this is what you're getting your example from. I don't know, but it sounds like a reasonable guess. So you can parade as a bachelor and not be a bachelor. Everyone in the world can believe you're a bachelor, and you can fail to be a bachelor if you are in fact married. All right, so we got a term for the difference between these two kinds of statements. We call certain statements that are true in virtue of their meaning analytic truths. Or sometimes this following definition is used: the statement whose denial is self-contradictory. The idea is that there are certain statements which, just in virtue of what they say, if you understand them, you can tell that they're true. No additional research is required. They're the sort of things that you don't have to go to university to find out. They're the sort of things you don't have to do hard work to find out. You just have to be a competent user of the language. Right? There's a lot of examples like this. Right? If Bob is married to Sue, then Sue is married to Bob. Right? If you know what marriage is, you know that it's a symmetrical relationship. You can't be married to someone and it fail to be the case that they're married to you. Anyone who's an ancestor of Bob is an ancestor of Bob. Once again, it's just a part of the concept of being an ancestor. Right. Bigger than is like this. If x is bigger than y and y is bigger than z, x is bigger than z. You can't understand the concept bigger and fail to appreciate this fact about biggerness. All right. Synthetic truths, the idea here is just the opposite of an analytic truth. Something's a synthetic truth just in case it's true, but it's not an analytic truth. Right? So doctors being cyclists, ophthalmologists being ornithologists, bachelors ceasing to be bachelors. These are things that are true, but not in virtue of what they mean. Right? You have to investigate the world in some way. All right. So test yourself. Are the following analytic or are they not analytic? All triangles have three sides. Analytic, right? Can't understand what something is, what it is to be a triangle. Every planet is an astral body. Yeah, if you understand the notion of an astral body and you understand the idea of being a planet, all ravens are black. Analytic or not? Yeah, it's true, but it's a synthetic truth. No uncle who has never married is an only child. It's analytic. You'll figure it out if you think about it for a minute. Here's one ought never to believe a logical contradiction. Any thoughts? Analytic, not analytic? One ought never believe a logical contradiction. What would you have to do to figure out whether or not that's true? Is there any kind of research you can do? Could you take surveys? This is a tricky one. We'll talk more about this in later in the epistemology section of the course. But if it's true, it's a synthetic truth. Here's a quick argument for that. Right? If you're one of those logicians who thinks that the liar is a true contradiction, it seems like it's rational for them to believe there are some true contradictions. Right? And that seems prima facie plausible, right? They're logicians, they're smart people, right? They think really hard and long about this. They've got reasons for thinking that the liar is a true contradiction. So if that's true, then 5 is false. It's rational for some people to believe logical contradictions. Murder is wrong. Synthetic? Anyone think it's analytic? Yeah, so here's the question. Is a part of the concept of murder the concept of a wrongful killing? I tend to think that it is. And I think that this is the difference between killing being wrong and murder being wrong. Murders are wrongful killings, but not all killings are wrongful. Now, we can have a debate about that. Maybe you could generate cases where there are... So here's how you'd refute me. You'd say, here's a scenario in which a murder occurs, but it's not wrong. And that would be the task. Try and generate a perfectly coherent example where there's a murder that takes place, but it's not wrongful. And if you can do that, then you've got an argument for thinking it's not an analytic truth. Everything red is colored. That's a texture of an analytic truth. Yeah, good. All right. All right, there's more I wanted to introduce you today. It's all right. The second bit of what I wanted to introduce you today is stuff that'll resurface later on in the course when we talk about epistemology and knowledge. Any contradictions before I let you go? Any contradictions? Any questions before I let you go? Any questions about contradictions, inconsistencies, the analytic-synthetic distinction? Yeah. Yeah, so an analytic statement is a statement that's true in virtue of what it means. Right? So the idea behind an analytic statement is that its very meaning guarantees its truth. So if something's an analytic truth, it couldn't possibly be false, right? Because the sentence means what it means no matter when or where it occurs, right? A sentence meaning is an essential feature of the sentence. So analytic truths are not just truths which, if you understand them, you're in a position to tell that they're true, but they're also truths that couldn't possibly be false. Yeah, yeah. Uh-huh.
When you were talking about inconsistent and contradictory statements, such as all is tall and all is short, I consider that to be inconsistent because both could be false, as in it could be this average height. Would that be a correct assumption or otherwise?
Oh, yeah. So I was taking...
Because if you imply that short just meant not tall,
that's what I was...
I see how it's a contradiction.
Yeah. So I think they're contradictories, but to say that they're contradictories...
Because I consider it like, all is overweight and all is underweight. It could be neither.
So there's two ways of being not tall. Oh, yeah, you're right. Okay, so... yeah. It should be neither. Yeah, you're right. Yeah, very good. You're quite good. So they're inconsistent yet not contradictory. That is the correct answer. Yeah, good. Thanks. I'll correct it for the next class to slide. Yeah, all right. We'll see you guys later. Hi.
Would you please explain the swan one again? Because I don't really get it. Like, is it supposed to be inconsistent?
Okay, so the swan one, all swans are either white or black. It's possible for there to be a pink swan. And I said neither because of the possibility portion of the second claim. So to say everything is one way or the other is actually one way or the other. Isn't to say something about how everything has to be. So it might be that there's no building on Earth that's more than a mile tall.
But it's possible.
But it's possible. So it might be that all buildings are shorter than a mile, but it's possible for there to be a mile-high building.
Yeah.
So that's why I